I've always wondered why you have to get so many high-voltage lines. You take the power from a power plant, raise it to hundreds of thousands of volts through a transformer, and then lower it down through a transformer when it reaches the user's area. Isn't that redundant? Today, I finally realized that high-voltage transmission is really beneficial, because the process of power transmission from the power plant to the user is usually a long distance. But the wires have resistance. This causes power loss, and the loss is proportional to the square of the current. The formula is as follows. If you want to reduce the loss, you must reduce the current. But power is equal to voltage times current. So if you want to transmit the same amount of power, the current must be reduced, and the voltage must be increased accordingly. In this way, the transmission over long distances does not lead to significant energy losses, thus increasing the efficiency of the transmission. In addition, because the current is reduced, the cross-sectional area of the wire required to carry the current can be reduced. This reduces the use of wire materials and lowers costs, which plays a key role in the transformer and what is the principle. In fact, to put it simply, is the use of Faraday's law of electromagnetic induction. That is, electricity generates magnetism. Magnetism generates electricity. When the alternating current through the primary winding, it produces an alternating magnetic field in the winding. This alternating magnetic field is transmitted to the secondary winding through the iron core. In the secondary winding, the alternating magnetic field induces an alternating current voltage, proportional to the voltage in the primary winding. The voltage transformation relationship of a voltage transformer is determined by the turns ratio of the primary and secondary windings. The formula is as follows. Okay, have you learned it after watching?